Hi, we're working on exponential and logarithmic graphing and transformation. So just a couple of rules. Remember, we apply the H and K, or the vertical and horizontal stretches first. I always start with my mother table, and then I multiply the y's by their vertical stretch factor, and I multiply the x's by 1 over the stretch factor, so 1 over d. Then I move each of the points H and K and apply that same transformation to the asymptote, whether it be vertical or horizontal. Exponential functions have a horizontal asymptote, and log functions have a vertical asymptote. Okay, let's get to graphing. So I started my table. Remember, each exponential function has its own mother function. So I used 4 to the x, and so this is 4 to the x. And then I went ahead and I multiplied the y's by 2 times y, since my stretch value is 2. So I did 1/4 times 2 gives me 1/2, so on and so forth. I didn't have the stretch value for d, so I just left those points the same. So I know that my graph starts at, has a horizontal asymptote at 0. I don't have a k value, so it's not going to shift. And my new points are going to be 0, 2, and negative, my pen's all over the place, 1/2, and 1/8. So a steeper graph here, getting closer to that horizontal asymptote. If I had an h and k value, I would go ahead and shift the whole graph now. Okay, my x-intercept is, there is none, it's undefined. My y-intercept is 0, 2. My domain is x is all real numbers. We should put the set of x. Y is greater than 0. And as x goes to infinity, y is going towards infinity. And as x goes towards negative infinity, y is going towards 0, which is also disguised as my k value. All right, we're going to look at logs next. So the first log graph, I start with my mother function, so log base 6 of x. And if you're having a hard time doing logs, what you can do is set up an exponential function. So x is equal to 6 to the x, y is equal to 6 to the x. And then just plug in your points that way. So 6 to the 0 power is 1, 6 to the first power is 6. And then since these are inverses, we switch the x and the y's. Okay, so this is my mother table for logs, for log base 6. So I'm going to graph 1, 0, 6, 1. So 6 to the first power is 1. And I have a vertical asymptote at 0. And then, so this is the original. What I'm going to do is my h value is equal to 1 and my k value is equal to negative 5. So I need to transform these. So I'm going to go to the right 1 and down 5. 1, 2, 5. To the right 1, down 5. So 1, 2, 3, 4. Ooh, that was 4. Try again. 1, 2, 3, 4, 5. Okay, great. So also don't forget to shift your vertical asymptote. It is going to move over 1 unit and down 5, but since it's just a line, the down 5 doesn't really affect it. Okay. So it's going to rise slowly like that. So my x-intercept is, we're going to have to solve for that now, and we'll do that in a second. My y-intercept is none. X is x has to be greater than 1. The range is y has to be, is all real numbers. It rises and falls, okay, towards infinity and negative infinity. As x goes to infinity, y is going to slowly go towards infinity. And as x goes to 1, y goes to negative infinity. Okay, so now we're going to do our x-intercept. I'm going to use this paper here. So we have y is equal to log base 6 of x for an x-intercept. Remember, we're solving when y is equal to 0. So log base 6 of x. We go ahead and snail this. Oh wait, sorry. I forgot this whole part about the transformation. X minus 1 minus 5. Okay, so I'm going to add 5. I get 5 is equal to log base 6 of x minus 1. And then I'm going to go ahead and change the form to 6 to the 5th power. So equals x minus 1. So 6 to the 5th power plus 1, so add 1 to both sides, is equal to x. So that is something really large. Let's see what the number is, because this thing is rising really slowly. Working calculator. Okay, so 6 to the 5th plus 1 is 7,777. So my x-intercept, 7,777, comma, 0. And that's it.